Okay, welcome back. In this video, we're going to be working on simplifying complex rational expressions. And so the plan basically is to talk about what that is and what is a complex rational expression, and then what it means to simplify it. So first of all, a complex fraction isn't just complicated. The word complex there doesn't mean what you think it means. There's a specific math meaning for complex in this case, and it just means a fraction whose numerator or denominator has a fraction in it. So it's like a fraction inside of a fraction. So you can see some examples here where we have a big fraction, and in the numerator or denominator, or maybe both, there's some other fraction. And then to simplify such a fraction, we need to apply some procedure, which we're about to learn, to make it so that it no longer looks like that. That is, it's smaller. It no longer has the property that there's a fraction inside of a fraction anymore. And as always, when we're simplifying, we want to simplify as much as we possibly can. So before we go any further, I did want to mention when you're writing complex fractions, it's a good idea to really emphasize how long that division bar is. For example, in this second one where we've got 4 over x over 5, this one, the big fraction, its numerator is 4 over x, the denominator is a 5. If you weren't is kind of emphatic about it and wrote it as 4 over x over 5, over here to the right. Now it looks like maybe the 4 is on top and x over 5 is in the bottom. So which is it? And it's not going to be equal. It's not the same. So it's a good idea to go ahead and make those fraction bars good and long so that everybody knows, do you mean 4 over x over 5, or do you mean something else like 4 over x over 5? Okay, so just be really clear about which one is your fraction bar, or your main fraction bar. There's 2 ways to simplify a complex fraction. One is that you can just write it as a division and then divide, as we learned. The second way is to use the LCD. So we're going to see the write as division way, and then the use the LCD way. Okay, so first of all, to write it as division, let's see how that goes. We're going to try 1/2 plus 2/3 over 5/6 plus 1/12. So remember that a fraction can be represented as a division. So this is 1/2 plus 2/3. And then that is going to be divided by 5/6 plus 12. And then we're going to simplify each of the parts that are in parentheses and then simplify further. So here 1/2 plus 2/3, the common denominator there is going to be 6. So we'll have 3/6 plus 4/6. And then we'll just sit on that for a minute. On the right side, we have 5/6 plus 1/12. We'll make all that 12ths. So that's 10/12 plus 1/12. And then that gives us 7/6 on the left. And then we're going to divide that by 11/12. So we simplified the numerator and denominator as much as possible. And now we're ready to divide. We'll turn the division to a multiplication. And the 11/12 will become 12/11, of course. So try to simplify whenever you can. And it looks like we have 14/11 at the end. Okay, so that's basically how it goes when you write as division. You simplify the numerator and denominator as much as you can, and then divide. Okay, so let's try that again. So here we've got 2 over x squared minus 1, and then that's divided by 3 over x plus 1. So let me first write that as a division problem. That's 2 over x squared minus 1 divided by 3 over x plus 1. And then the denominator there on the left side, I want to factor that. We'll have 2 over, actually, what am I doing? I don't need to factor that. I was thinking about adding, which we were just doing. No, I don't need to factor anything here, sorry. So that's 2 over x squared minus 1 times x plus 1 over 3. Okay, now I do need 2 factor because we're going to end up canceling out that factor of x plus 1. Okay, so now the factor of x plus 1 is going to go away, and that will leave us with 2/3 or 2 over 3 x minus 1. I guess that would look nicer like this, 2 over 3x minus 3. Okay. So let's try more examples. Okay, in the next one, we have 1 over x plus 1 over y, and we're going to divide by 1 over x minus 1 over y. Okay, so then let me do the addition and subtraction in the top and bottom first. So our common denominator is going to be xy. So in the first fraction, I'll multiply the top and bottom by y. The second fraction and x. Down below, we'll do the same thing. First fraction gets a y in the top and bottom. The second fraction gets an x in the top and bottom. So now we'll have x plus y over xy. And then down below, we'll have y minus x over xy. Okay, so I've simplified the numerator and denominator separately. Now we can go ahead and write that as a division. We'll have x plus y over xy divided by y minus x over xy. Okay, so this will give us x plus y over xy times xy over y minus x. Now these common factors of xy will divide out. We'll get x plus y over y. That's x. Okay, and that will do it. Okay, so we've simplified it down to the point where the numerator and denominator no longer have a fraction in them. Okay, this one looks big, but that's okay. We'll be able to do it. So on this one, why don't you pause the video and try it yourself, and then we'll go through it together. And see how you got. All right, so now I'm going to simplify the numerator, simplify the denominator, and then we'll divide. So up top here, we have b, which is the same as b over 1. I'll multiply the top and bottom by b plus 5. Okay, and then the second fraction will be left alone. Okay, down below, the first fraction we'll need to multiply by a b minus 5 in the denominator. And then the second one we'll need to multiply the top and bottom by a b plus 5. This is one of these situations in math where it looks like we're making it worse, right? Our whole goal was to simplify this thing, and it looks like we're making it more complicated. And it's true, we are making it more complicated, but it will get better. Okay, so now in the numerator, we have a common denominator of b plus 5, so we can add. We'll have b plus 5 minus 3b over b plus 5. And then all that, notice I have a nice long fraction bar there. 2b minus 5 plus b plus 5. And that is over plus 5b minus 5. Okay, now that we have the numerator and denominator written as single terms, we can rewrite this whole thing as a division. We'll have b plus 5 minus 3b over b plus 5. That is divided by 2b minus 5 plus 5 divided by b plus 5, b minus 5. Okay, it's already getting a little bit better. We can rewrite our division now as a multiplication. Also along the way, I'm going to simplify some of these things. So this first numerator is going to become b squared plus 5b. Then we'll have minus 3b. I guess I could have done that earlier. B plus 5 down below. Our divide is going to become a multiplication. And then the b plus 5, b minus 5 will come up top because we're forming the reciprocal. And then what was formerly the numerator is going to go downstairs. So it will, and also I'm going to multiply things out. We'll have 2b minus 10 plus b plus 5. Okay, so now we're almost there with this one. So a couple of things are going to happen. We're going to divide out that common factor of b plus 5. And then additionally, we'll continue combining numerators, combining like terms in that numerator and denominator. So we'll have b squared plus 2b, and now that's over 1, times b minus 5 divided by 3b minus 5. Okay, and it doesn't look like we're going to end up getting any simplification out of this, so it's better to just multiply everything out. So let's do that. So we will have b cubed minus 5b squared plus 2b squared minus 10b. In the top, and I guess there's a little more to be done down there, 3b minus 5 down below. B cubed minus 3b squared minus 10b up top, down below 3b minus 5. All right, so this one had a lot of steps to it. Go through it, make sure that you understand all the steps. If you did this but didn't do things in the same order as me, it's not necessarily wrong. It's just the order I've chosen to do some of these steps in, but that's how that one plays out. Okay, so this has been the method of basically simplifying the numerator, simplifying the denominator, and then dividing. So the next method is using the LCD. And so taking a look at this first example, we have 1/2 plus 1/5 divided by 1/10 plus 1/5. The denominators we have are 2 and 5 and 10 and 5. And so the least common multiple of 2, 5, 10, and 5 is going to be 10. So what we'll do is we'll multiply the numerator and denominator of the whole fraction by that 10. So we're going to multiply the top and bottom by 10. The pink fraction I just wrote in has value 1. So multiplying by 1 doesn't change the value any. It's just going to change how it looks. Okay, so now we'll distribute that 10. This is going to be 1/2. Let me show how this is going to look. All right, so here I've multiplied through the 10 in the numerator and denominator. That is, we've distributed it. And so we'll have, on simplifying, 1/2 times 10 is a 5. And then 1/5 times 10 is 2. 1/10 of 10 is 1. 1/5 of 10 is 2. Okay, and so that makes it so that the fractions are gone. If at this point the fractions are not gone, then either you picked the wrong LCD or you didn't simplify or multiply correctly. So this will give us 7/3, and that's the end of it. Okay, so we'll see, of course, more examples of this method, but I did want to address the question, which method should you use? Simplify the top and bottom and then divide, which we saw before, or use the LCD. For some problems, one way may be easier, but often it really just doesn't make a difference. It's up to what you personally prefer. If you like, you can just get good at one way of doing it and just do every problem that way, or you can practice both. For me, it doesn't make a difference. Your future professor may care, so you can ask them at that time which way they would like you to do it, or do they need you to be able to do both ways? Okay. All right, so then let's try this again. So here we have 1/x² minus 1/y². And down below 1 over x plus 1 over y. The LCD of the denominators you see here is going to be x squared y squared. So we're going to multiply the numerator and denominator by x squared y squared. So then next we're going to need to distribute that pink part into each term within the numerator and denominator. Okay, so I've multiplied each of the terms in the numerator and denominator by that LCD. So now we're going to go through and simplify each of those individual fractions. So in the upper left, we'll see that a common factor of x squared will cancel out. That will leave y squared. And then minus. And then that factor of y squared will divide out, leaving an x squared. Okay, down below, we'll see that 1x will divide out, but 1x will remain. So we'll have xy squared. And then for the last term, we'll see that 1y will divide out, leaving x squared y. Okay, so that is how that's going to look. Let me just check and see. It's simplified as far as not having any complex fractions anymore. Let me check and see if we're going to be able to cancel more out of it. The numerator is a difference of squares. So let me factor it that way. Down below, it looks like there's a common factor of x, y. If we factor that out, we'll have y plus x. Yep, sure enough. And so we are able to divide out that factor of y plus x. So we'll have y minus x divided by xy. Okay, so I'm glad I looked. All right, more examples to come. All right, so here we'll multiply the numerator and denominator by the product, x plus 2x minus 2. Okay, and that's going to multiply into each of the factors or each of the terms in the numerator and denominator. For the numerator, you'll see that the x plus 2's will cancel. We'll be left with 3x minus 2. And then down below, where the 5 is, you'll see that the x minus 2's will cancel, and you'll be left with 5x plus 2's. And we have minus 3. And then the x squared minus 4 is x plus 2x minus 2. So the entire denominator there will cancel, leaving us just the 3. Doing it this way is kind of satisfying because you get to see all the fractions go away kind of all at once, but whichever you like. Okay, so this cleans up really nicely. We get 3x minus 6 over 5x plus 7 in the end. Okay. All right. We have more examples to do. Okay, so in this one, to find the least common multiple, let me go ahead and factor that quadratic denominator we have. That factor is x plus 2x plus 5. Okay, so then we're going to multiply the top and bottom by x plus 2, x plus 5. Okay, so then once again, we'll have each of the factors in the numerator multiply and denominator get multiplied by that product that is in. All right, so taking a look at that, I've multiplied everything by the x plus 2, x plus 5. So we're going to see a bunch of things cancel out. The entire, everything but the 3 in the numerator is going to be canceled out. Down below where the 4 is, we'll see the x plus 2's get canceled out. And in the last fraction, we'll see that the x plus 5's get canceled out. So up top, we'll have a 3. And then down below, we'll have 4 x plus 5's left. And then an x plus 2. Okay, so we're almost there. We just need to simplify this a little bit further. This will give us 4x plus 20 plus x plus 2. And that will be 5x plus 22. Okay, all right, so we have just one more example to do. Okay, so in this one, the LCM is going, or LCD is going to be x plus 1, x minus 1. We'll multiply the numerator and denominator by that product. Okay, don't forget to multiply all the terms by that product. It's easy to neglect that 1 that is off to the left, but we won't forget it. We'll have x plus 1, x minus 1, plus x plus 1. And then we'll have 3x minus 1. Okay, make sure you understand where each of those parts comes from, and if you're not sure, then let me know. Okay, so then all we have to do is clean things up. Okay, so we'll have x squared plus x over 3x minus 3. All right, and that will do it. That finishes up this section for us. Let me know if you have any questions on it, and then have a great day.